one of the most common and versatile methods of joining metal. This is the SMAW, or shielded metal arc welding process. Electric current from a welding machine produces an arc between the base metal and a consumable electrode, which is the welding rod. That arc burns the flux coating on the rod, creating gases that shield the weld area from coming in contact with oxygen in the air. The gases surrounding the arc are superheated, causing the base metal to melt, while the filler metal from the rod is being deposited into the molten puddle. Whether you're learning to weld to build something or make repairs, the first step is to learn how to consistently run a good weld bead. Before we start burning rod, though, there are a few things you should know about the equipment we'll be using. So let's begin with the welding machines. The job of a welding machine is fairly simple, and that is to provide a steady, controllable current to the electrode. Now, regardless of the size or shape, welding machines will provide either alternating current or direct current to the electrode. And this little machine gives you the choice of either AC or DC. The main advantage of alternating current is that it's easier to produce. They use simple transformers, so you generally get more power for your money. This one will give you 225 amps on AC, but only 150 amps on DC. If you think about alternating current, the electrons are moving back and forth, and at the point where the electrons change direction, the flow or current actually stops. Certain welding rods have been designed with stabilizers in the flux to help maintain and control the arc through these amperage lags. So if you're using a welding machine that provides alternating current to the electrode, you want to make sure to use a welding rod designed for alternating current. Most welding shops and professional welders use machines that provide direct current to the electrode. And in my shop, I use a 250 amp DC machine. Direct current provides a steady flow of electrons in one direction. The polarity, or direction of flow, is determined by how the leads are connected to the positive and negative terminals on the welding machine. And many of the newer welding machines have a switch to choose the polarity. DC EP, or DC plus, is direct current electrode positive. The electrode is connected to the positive and the ground is connected to the negative terminal. Current is generally considered to flow from negative to positive, so with the electrode positive, the arc actually travels from the metal up to the welding rod. This causes the tip of the rod to superheat. For general purpose welding, all the common welding rods use DC EP with the electrode positive. DC EN, or DC minus, is direct current electrode negative. The electrode is connected to the negative terminal and the ground is connected to the positive. With DC EN, the flow is from the welding rod to the metal, so the rod stays cooler and the metal gets the heat. This is used with certain rods for high-speed sheet metal welding. When you're starting out, you'll probably be welding with a machine that's put in front of you. And basically, if it's in proper working condition, you can weld with it. Keep in mind, though, that welding machines will weld differently. Even two identical machines may not operate quite the same. So while you're learning to weld, try to use the same machine as much as possible. Welding leads are insulated copper wire and come in sizes like a number 4, 2, 1, and single aught. The larger the number, the smaller the diameter. The size welding lead you need to use depends on how many amps you'll be using and how long the lead is. And welding supply stores have charts to determine the size lead you need to use. On the end of the main lead, I use a quick connect with about 15 feet of number 4 lead and the electrode holder. This is called a whip. The smaller lead is a little more flexible and easier to deal with. This is a 200 amp electrode holder. Larger ones like 250 or 300 amp are available if you're mainly using big rods with high amperage settings. But for general use, the 200 amp is more comfortable. And I usually call this the stinger. Another type of electrode holder is available where you stick the rod in and twist the handle. If you need the rod at a different angle, you can just bend it. You also need a ground clamp. And I use a quick connect here too, in case I need to add more lead. Now, the light from arc welding is extremely bright. You need filter lenses both to be able to see the molten weld puddle and to protect your eyes from getting burned. These are typically available from a number 8 to a number 14. The lower the number, the lighter the lens. From what I can tell, some people are more sensitive to this light than others. A number 8 filter lens is way too light. Industry recommends a number 10, and I use a number 9. The lens has to be dark enough to protect your eyes, but light enough so you can clearly see the weld puddle. If you're welding with big rods using high amperage, you may want a shade darker lens than normal. And if this filter lens gets chipped or cracked, replace it. To protect the filter lens from sparks or getting scratched, I use clear plastic lenses in front and in back. There's a gasket that goes in first to seal the lenses, and everything's held in place with a clip. After you install the lenses, hold the hood up to a light and check for leaks around the edges. When you start welding, check it again. If any light from the arc is leaking around the edges of the lenses, it'll burn your eyes for sure. Also, replace the clear lenses when they get dirty or scratched. Having a clean lens makes a big difference in allowing you to clearly see the weld puddle. Okay, the last thing we need are welding rods. So let's take a look at some of the common ones. Some of the more common welding rods for carbon steel are E6010, 6011, 6013, and 7018. And the numbers are written right on the rods. These numbers actually mean something, so let's take a look at E6010. The E designates an arc welding electrode. The first two numbers, in this case 60, indicate that the filler metal has a tensile strength of 60,000 pounds per square inch. Depending on certain conditions of the weld, you may get a little more or less, but it'll be close to that. The 70 and 7018 indicates 70,000 pounds per square inch. So the first two numbers indicate tensile strength, and tensile strength is the force it takes to pull it apart. The third number indicates the position the rod can be used in. A number 1 shows that the weld puddle solidifies quick enough so this rod can be used in any position, flat, vertical, horizontal, or overhead. A number 2, like in 7024, indicates that the molten puddle remains so fluid this rod can only be used in the flat position or for a horizontal fillet, which is more or less flat. The last two numbers together, here it's a 10, indicate the composition of the flux coating. And this flux is what makes the whole arc welding process possible. As it burns, a gas is created that purges the weld puddle, keeping the oxygen in the air from mixing with the molten metal, which could cause gas pockets in the weld bead called porosity. The flux also helps stabilize the arc, and it